These dome structures are used to cover large span structures like sports areas and churches, and also for coverings of the circular tanks. Circular tanks in the sense, the roof coverings is provided as a domes because when we use flat slabs, it will be costing more for the thickness and for the reinforcements provided. But in dome structures, the cost is very less for construction. Example, for reinforcement will be reduced when we use domes, and the concrete layers, the thickness of the concrete will also be reduced when we use this dome structures. And as we know, for the design of RC elements, we have two methods, limit state method and working stress method. These dome structures are designed based on working stress method, because large span structures are always designed as per working stress method. Before getting into the dome structure, before getting into the design procedure of the dome structure, let me tell about you the parts of the dome. In the parts of the dome, this arch structure is called as dome, and this beam, provided beam, this beam is called as ring beam. So when we combine, when we are going to do design for a dome, we want to design for that dome structure and also for the ring beam. Just we want to design both for design for domes and also for the ring beam, which has surrounded by this dome. Okay, and this one is H. This H denotes the rise of the dome. H denotes the rise of the dome. And this D is your diameter of the dome. Diameter of the dome structure. Inside, if it is a circular tank, this is the dia of the circular tank. That is size of the diameter of the circular tank, and this is the theta angle subtended by the meridional axis of that. That is circumference of this any structure. For example, if it is a circular tank, it is angle subtended, meridional angle subtended by that surface of the tank or by your structure, large span structures. And this R is the meridional radius. R is the meridional radius, and the angle subtending this meridional radius is your theta. Okay, theta. Okay, and then we so listen. H is the height of the tank, and D is the diameter of the tank. And R is the radius of the meridional radius of the dome, and theta is the angle subtending that meridional radius. And again, we just come to design procedure. In coming to design procedure, generally we know that design means we want dimensions in the sense cross-sectional areas and reinforcement details. Reinforcement in the sense what type of dia we are going to provide, and what type of reinforcement, what type of spacing we are going to provide for the circular tank. Especially here, we want to design for first one dome and second one for this ring beam. For dome, we want to mention the diameter of the rod, that is one reinforcement detail, and size in the sense thickness of the dome. Size in the sense thickness of the dome. So for ring beam, you want reinforcement details, and ring beam you want dimension of the beam. Dimension in the sense, for beam we know that breadth into depth. Okay, for taking up the dome structure, first we want to calculate this diameter or dimensions of the dome. For dimensions of the dome, we want to get into know that dome means thickness of the dome. And for this thickness, we have one criteria called, and for this thickness we have one criteria like the thickness of the diameter, the thickness of the slab should be in the range of 500 by D. In 500 by D means this 500 is the span of the